Okay, let's start. Welcome everyone to this second webinar of Impact for Revit. My name is Linus Karlsson and I'm a technical support and development member of StruSoft and in particular Impact for Revit team. I have my colleague Desislava Borisova on as well, and she will answer all your questions. I hope that you hear me well and you see the screen. If not, please try to notify me. Otherwise, we will continue start with the webinar. We have a rough agenda where we will of the topics we will go through. We will start with a little bit of the definitions of both element or all the element types that we have available. Many of them are similar, so I will go into specific details on some of them to just show the differences. Then we'll go over to this cost materials and see how the setup looks like for those, and we will continue with a little bit of tools, how to copy elements, how to insert cost materials with a template, so you get the placement a little bit automatic on several elements at the same time. We will then continue with the Rebar templates. So basically you reinforce one element and then you use that reinforcement to reinforce other similar elements. And in the end, we will finish with some shop drawings and some settings and features around there. And we will have time for some Q&A in the end. So I will switch screens now. So this is the building that, for those of you who attended the first webinar, I think you remember this. It's a small and simple model that shows a little bit of every element type that we have. And we will continue with this one as a base, and I will go into details a little bit. So this is the same, but in Impact for Revit. First of all, we wanted to present a little bit about the different element types and how, for instance, we add the lifting types or the lifting setups depending on mass and so on. So in Revit, there are two general differences between the families. It's either loadable families or system families. And we have a combination of both. So you see all the walls and the slabs here, both solid slabs and form slabs are system families, while column beams and the hollow cores are loadable families. And they work a little bit different, but like in the end, as a base, let's say. So when we look at it from a Revit perspective, the loadable families are, as you probably know, created by the user. So you create in a separate file, you create the geometry and put parameters and other information on it, and then you use them in the actual model. While the system families are basically, just families that are created through the program. So you don't need to prepare those families in another file, but you prepare them in your project template basically. So from here we have we have to use Revit to come up to this level. But then the impact part is to add information like metadata, like what type of element it is, what let's say, names we want to have in the element marks and so on. And that we do with our tools. So let's take a look at the system families for walls at first. So I will take a look at the sandwich wall definition I have used. So this one is created from scratch before the first webinar. And while we create this, we are basically just creating the system families as you do in Revit, but we are adding a lot of other information. So you can say that this part here with the different layers and the materials for those are set up for as the system families, but in this definition, and the rest are done are the data that we need for the impact software to work. So we can start here with the production. So we have different type of castings for the insulated, not the insulated wall, but sandwich walls. So it's either if the inner panel should be up in the mold or down. And this is, of course, which side you want the best finish on. Then we have the reinforcement template that we looked at the last webinar, where we reinforce the main reinforcement with the edge reinforcement around windows and the mesh automatically. So here you can set up a default type there. The lifting tool, or the way we insert the proper lifts is set up here. So it's basically a setup of rules where we add the rules of different dimensions and different types. We have 3 different options of 1, 2, and 4 lift points, and we add the cast materials that are going to be the lifts. And for each of the cast materials, we add on the information of the capacity of mass each cast material can lift. So depending on this, the mass and the capacity, in combination with the rules that we set up, we will insert the proper lift on the proper element. So you see here that this element got 2 lift points, and they are a little bit bigger dimension, while these walls here have 4 each, but you can see that they are a little bit smaller, so it's a smaller size basically. We also have a setup for the bracings, as you can see here. So everything here is just for making it possible for you as a user to get both lifts and bracings into your walls automatically with the placement that you wish. We have a little bit of different options here. And then we have the naming conventions. So we have the naming of the drawing, so the prefix. So we will have, in this case, SW and dash, and then a number of which element it is. So basically the assembly number with some modifications. Also the prefix of the element mark. So in Impact, we don't use the assembly name as the element mark, but we add our own. So we can add this prefix. So this is the prefix for the element marks. And then we have the other 3 here that are more into categorizing. These 2 here are more into categorizing how to, let's say that you have 5 different definitions of sandwich walls, but in the project manager that we saw here in the beginning, you might want to filter out all the sandwich walls of one kind of type. Then you can specify that information as group or product here, and as such. So this is the setup of the system families, and they look like for the lifts and so on. It's a little bit similar for the system families for the the slabs. So basically it's identical, and then for the slabs we have more settings according to that element type. We can just take a quick look at a solid slab here. It's pretty much look the same, just that we need to specify a little bit less than for the sandwich wall, since it's just as one solid plate with specified materials. Then we have specific ones for slabs if we want end caps to be inserted automatically. The lifting is similar, so you set up the rules, 2 or 4 lift points in this case. You add the families for the lifts with the capacities and so on. And for the slabs, you don't have the bracings since they are not used there. So there are similarities, and but some things differ. And this naming tab is basically the same. So this is basically the system families. But when we look at the let's say the loadable families, we have some other ways of doing this, since this is not done in a in the software directly. So we can go to definitions, and I think I will show a holocore. So this is the loadable families that we use for the holocores. It's simplified with the cores that are just circles, but it's a good example. So when we in pure Revit have created this geometry in this file, there are stuff that we need to fill in as both parameters but also settings. So if you go to the family types, there are some parameters that needs to be there. So it's these that we can see here. And if you remember how it looked like in the naming tab, most of them are according to that. So we have the drawing prefix, the element mark prefix, as you see here, the group and the product. And then we have one specific one that indicates what sort of element type it is. So here we need to specify if it's holocore, if it's a column or a beam and such. But here we don't set up the liftings as we did for the walls and the slabs, but we do that under the impact tools. So we have the tool to set up the liftings for these holocores as well. It looks pretty much the same. A little bit graphics are a little bit different, and there are some other options than we saw in the other element types, but in the big picture it's the same. And here we can also add automatic core fillings around the lifting points to strengthen the holocore slab. And for holocores we also have some settings, because both about the general geometry of the section, the cores, but also as we all know, when we draw the holocores, it might be that we need to cut 1 or 2 elements, and there in these settings we have a tool to specify the cutting zones. So these green crosses here, or marked areas, are a symbol for where it's okay for the program to cut the element. So this will happen automatically, but the user can decide where this is okay to do. And why we put it here is basically because we have strands in between that we don't want to cut in. So here we also put up the strand positions, and we categorize them as in this case we have 3 different. So we have outer bottom and inner bottom. So this is basically the inner bottom, and here's the outer, and then we have the top up here. And these categories can be used and strand positions can be done to create the different strand patterns that different elements should have. Then we also have some connections to the calculation softwares that StruSoft provide. Some different setups of how to connect the hollow core slab to the rest of the structure, like the walls and stuff, and beams and so on. And it's very similar to, these settings are very similar when it comes to columns and beams. It's not as advanced as not as advanced settings as for the hollow core, since we don't have the different cutting zones and so on. But for a pre-stressed beam, we have the possibility to set up the strand positions and so on. So, and also for both those element types, we can put lift and bracing settings. Yes, so that was a little bit about the definitions that we use for creating these models. And a lot of, or another definition that we are using a lot, we've covered a little bit, is the custom materials that we have for lifts, for bracings. And you see here in between the elements here that we have some connection loops. So basically all the custom materials are loadable families with and they are created as generic models. So I want you to show a little bit how that looks as well. And so I will go into the custom materials tab here, and I will just take a look at this FPL here. So it's very similar to the hollow core column and beams families. So we have a family that will represent the geometry. And as you saw here in the other picture, we are using the strength of Revit with parameters and so on. We apply some parameters that are needed to be for the element to be saved in the database, and so we can use our impact tools to actually like apply the different custom materials in different ways. So I just wanted to show basically like how to go from a family to actually draw the custom material, and it's pretty simple. So this is a pretty simple custom material. So I will just make an example of this. So instead of 100 by 300, I will do it 100 by 350. So we have a little bit of a difference. I will change the length to 350. And one thing that is very important is the sim mark. So it's basically the name of the custom material, and it needs to be unique, because that's how we separate and like pick specific custom materials in different parts of the modeling. So here I want to change this. So I will take like 98, because I don't think we have used that number yet. So we hit apply and OK. And then I will just save this family as I normally do. And it will be saved in the project folders for impact, so that our project or our software knows where to find it. So right now I could start to draw custom material and I think that I could draw it, but I just need to say tell impact that this family is connected to this specific custom material, because if we scroll down in this list, we don't have this 0398 here. So the highest number is 40. I will just put 0938 or 0398, sorry. And I will put the group 03. I will find my family. And you see that I got the preview of it here. So now I can just go to draw. I can go, yeah, find it here. So fastening plate 98. I can decide what dimension type I want. I want to center this one right now. And then from whatever view I can just insert it. And when I save this wall next time, this custom material will be saved to the database. So you got the information to the production and so on, and other ERP tools. You can also, when you create the shop drawing, you will get this dimensioned automatically and so on. So it's very, very, very great functionality of it. So this was a little bit about definition. So basically the core of impact for Revit. So basically what we need to create the different models of our projects. And I will now continue a little bit with some some features and functionalities that will make this modeling process go a little bit faster. So the first thing I want to show you is how to copy elements. So let's say that I've created this, and the elements on the slabs basically on the floor. I want just to copy these because I'm finished with them, but I need copies here on the third level as well, and also the columns and beams. So then I can just do like this. I can start with the columns. So I will mark my 3 columns. Sorry. Okay, I will start again. And I will just copy and move elements. This copy move element is an impact tool, basically. So here you can either just move them. So maybe you need to move them a little bit to any direction or to another level. Either you want to copy the elements to some place or copy it to on the same level, or you need to copy it to another, which we are going to do. So these elements are on level 1 hydrogen, so I will copy them to level 2 now. So basically just select that, and now I got identical copies here. It doesn't look, it's not a very detailed element, the columns, but we can do the same for all the cores and the beams. And the reason I select them in different orders is that they are basically different categories, and it works more smooth if you do it by category than by just taking everything at the same time. So now I got these, and then I will take the rest. Like this, and then we go to impact, copy to level 3, now hit OK. Okay, I think that I didn't do it properly. I think they were marked, but maybe not. So let's just do this one more time. Okay, it's something that happens when I mark the elements. I will try to just do these one more time. Otherwise, I think you saw the strength of it. Yeah, never mind. I will look into it later why I didn't get the other ones, but I think you see the big picture of it, and I hope that you see the strength of it as well. Let's continue with the sim templates that I talked about before. So for you who didn't attend the first session, I can just quickly show you a little bit what we did. So if I change the transparency a little bit, you see that when we divided the walls and we needed to apply the end caps to connect, we used something called joints to add some custom materials that we will be used when we actually joining the elements on the construction side. And that we did for all the vertical cuts. If I reset here, you will see that it's also applied on in the corners, but we don't have it here between the elements horizontally, and that's what we are gonna take a look at now, how we can do this. And one of the most simple ways is something that we call custom material templates. And what that is basically we decide that if this end cap is in the bottom, we will insert this custom material with some rules. So I will show you a little bit of this definition, and then we will apply it for the walls and see the results. So basically, I say here that the end cap that is named 21 will be adding the 0599 custom material, which is a tube, and this one 13 will do the 0215. So let's just look at one of them. So here we say what element type it is and what end cap, and then I will just apply like the custom material. I will place it with some rotation and place it on specific sides, and I will just move it with some values here. I can also add countersinking and some annotation text and so on. So this means that whenever this end cap is used and I apply the template on a wall with this, we will get this 0215 custom material implemented in this direction. And now you see the end cap. Yeah, you see the thickness of the wall. So it's basically like if I should rotate it 90 degrees, it's the bottom of the element, as we will see in a couple of minutes. So I specify how to place it in this direction, and I can specify as many as I want here. And then here I got all the 4 main sides of the element. So if I want it on top, which I want, because the bottom elements I want to have this 02 15. Sorry, I was wrong before when I said it was the bottom. It's the top. But then I have 2 different options of setups. Either I say that I have the length, and then I divide. I want to insert 2 custom materials with some rules here, or I say that I want to place them 600 from each side, and then 1200 in between them as spacing. And then one of the spacing needs to be a little bit smaller or bigger, since it's not possible to get even values all the time. Then I want to have the same in the bottom, and here I got this 0599 custom material. So I have the same because I want them to align in the bottom and the top elements. And then the sides that I want them to place, I just zero them out like this. So then I can just, let's say I will take the walls here on this side, on this side. So I take these, and now I'll just go to this apply custom material template. I select my template, and yes, that's fine. Yeah, so if we do the same drill again, and isolate two of the elements so I can see more properly. I will see that on my inside, on the top, I have these pipes inserted, and in the bottom I have it's a little bit hard to see, but I got these other cost materials implemented, and maybe we can see it in wireframe a little bit better. A little bit, but it's yeah. And this is of course for all the elements that I told to be implemented on. So maybe we can see it in shaded. So I will bring down. Yeah, it's a little bit hard now, but you see here that it's implemented. Yes, so this is one powerful tool, but we also have another tool that will, it's a little bit more simple. You don't need to specify it for different end caps. You can just say that you are more using different spacing and rules in that sort. So I will just take this wall as an example. And this command or feature is called Smart Cost Material. So here we basically just, I will put this on project level. I will create a new row. So I will put a JPL plate here of 150 by 200. So it will be inserted here. Then I can just say that it should be 500 from the edge. And I see here the main geometry. So the height is about 3 meters. So I say that this one should be inserted at 2800. I don't want a spacing here. I just want 3 instances all the time. And the end of set should be as the start. So I will say 500 here as well. So this will mean that for all the walls that I apply this on, I will get 3 plates, 500 from each side and 2800 from the bottom. And the length of the element doesn't really matter because the spacing between them here is not specified, so it depends on the length of the element here. I will just save this configuration as webinar. I will hit OK, saved, OK, and I will hit OK. And now I apply it for the wall. And you see, yeah, now it's on the inside, so we can isolate it. So the plates are placed here on the top. So what about we implement it on this element as well? So this is much longer, as you see, than this one. So I will go to the same command, but instead of setting this up, I will just select my level, and then I will select the setup. So this is very simple, so it takes no time to set up, but let's say that you have 10 rows here with different cost materials and different rules. It's very smart to save it and just apply it on other walls here. You see that if we isolate these two again, the spacing between them differ since the length of the element differ as well. Yes, what's next? Yeah, rebar. So I told you about the rebar templates as well, and I can just go through that a little bit. I will just isolate some elements like this, and I will prepare the view a little bit. And I'll actually show the rebars. Oh, sorry. Yes. So let's say that I've reinforced these two. And you see that these elements are basically identical. And it could be that this one is a little bit longer than that one, but it should have the same reinforcement, or the main reinforcement at least. What I can do is I can just save this setup of the reinforcement, So I will just go to this Rebar template that I've prepared. I will go to the common level, and it's for the inverted T here, as we have the beam. So basically, I just reinforce this with the Revit, and then I mark this and save the new configuration, and then I will get all these data with the constraints and so on specified. So instead of putting all the reinforcement on all elements, I can just put up some rules that, for instance, these N stirrups should have different covers to different sides. Some are to cover and some of them are constrained with offsets. So with these rules, and then we have a lot of different reinforcement bars and stirrups. But what I can do with this is basically take, now I have just one here, but I can take as many as I want, mark them, and just apply this inverted T. And yeah, I will get a new mark. So let's say that this took 5 to 10 minutes to reinforce, and now this took 30 seconds to reinforce. So it's very powerful if you have this set it up. And now I got it for the reinforcement rebars as well, or rectangular columns. I'm sorry. And now we can just select this. But let's say that I cancel my command and just start the rebar templates. So it's not only for columns and beams, but you can do this for all the wall types, for the corbels, panel thickenings, and stairs as well. Yes, I will. The next thing we are going through is basically the last thing, but it's very important, and that thing is the shop drawings. And to make it easy to work with impact, with elements, and to make it easy to create shop drawings that are very similar looking and automatic, we need some sort of template. And we are using something called shop drawing template, that we call it, which is basically prepared before the project, so it's prepared in your standard, and then you can use it and modify it during your project. But it's basically a Revit template file type in combination with an XML file that stores the data that impact adds. So if I go to this file, I will just show you a little bit of the setup. This one we can skip. So basically here I set up the views I want. So right now I just want one inner panel and one outer. I want a horizontal and a vertical section. I want the end caps to be inserted. And I have two lists here for both the custom materials and the openings. Then I have like information like if the element is ready for production, the element mark, what the mass is, volumes, and so on. Here you can put more parameters that are specific for your company. In this lower corner, we can add some product information that doesn't, we don't see that now, but we'll see it in a minute. Which designer who created this drawing, and the person who checked and approved it can be inserted as well. In this example, we have two different sheets, one for the main and one for the reinforcement. So here on this second sheet, we will see the reinforcement in the different panels, and also a 3D model to just make it easier to orientate a little bit. Here we'll have two lists, one for the reinforcements like the rebars and stirrups, and one for the mesh. But here you can customize in many different ways. So this is basically the setup of how it looks like. And then we want something to come pretty much automatic, and that we have the shop drawing settings for. So in this first page here, you set up what element type it is, what default drawing status you want, and a little bit other stuff. Then you have the views, where you define the different views here. So these views are basically the ones that we saw on the first sheet. So I will just, to make it easier, I will just change the reinforcement here. So now you can see that the views that are available is basically the views that I have, and also the schedules. So the 3D inner and outer panel, and the two different schedules. And here I just decide the position of it. If I want to change it, I just pick a new one. I say what type of view it is. So it's 3D, plan detail and stuff. And we have a lot of settings for the, not for the 3D, but let's say this inner panel. I just want to see the bars for the inner panel. Then I set here either inner, outer, or all. And when we look more at main here, we take the inner panel as well. We see that we can set up different categories of objects that should be dimensioned, and what type of dimension they should have, what side of the element or the view the dimension will be added. And let's say for the custom material, we have some tags with some symbols that will be added automatically as well. So this is basically the setup. It's very customizable and very powerful. So let's see how it looks like when we have created. I've generated a shop grid with this element here. So I will just go and find it. This one. Yes. So here you basically see that this is the first sheet that we saw just a minute ago, but we have some other element here because this is the actual element that we created the shop drawing for, and in the template it was just a dummy element that just show a little bit of the size and so on. But we see here that stuff are dimensioned, so you see that the cost materials. Now the description is a little bit long, so here I could just go into this family tag and just lengthen it a little bit so that all my annotations is fitting on one row, so it looks better here. But yeah, everything that I want to get dimensioned is dimensioned. I got the end caps description here. And you see that here are the tags that I talked about. So these numbers in the boxes refer to the list here, where we got the different cost materials. And I can decide to dimension different stuff on different views, basically. And you see here that I got the 3D view, which I didn't get on the template. But I created this this shop drawing before. So before we end this the second webinar here, I will just show you how to create or add this view, just for example how to add. But let's just take a look at the reinforcement real quick. So I have two different sheets here under my assembly. Where in this case I have just my mesh and my bars. I don't have the annotations, but I can turn that on. Or you can just do it one by one by activating this view, and maybe just go to annotate and like tag all. And Rebar tags like this. And this can also be done by the program automatically. But here you have the list. In our case, we have decided to put a shape image, some, both the item numbers, like the name of the bar, how many of each, the quality and the dimension, and also the shape code right here. And also the mesh, we have the name, the area, quality, and we end up with dimension and the mass of it. But all these schedules can be customized, as I told you about before. And in this 3D view, I can get a proper, or like a, I can get a more simple view of how the bars actually should be added. In this case, I might change the setting of how I see the actual elements, so that I don't get the hidden lines all the time. And I can also maybe change the color of the custom material, or the of the rebar, so it's more clear. But this is very customizable as well. So to end up, I will just show you real quick how to easily add a view on the shop drawing template. And I will do it for the 3D view, but you can do it for any other view, and it doesn't matter. It's very simple. So basically, we just create a new assembly view here. We use the 3D here and hit OK. Then I will just go away from this. So the 3D view, I know that this one, because that one is used for the reinforcement. So I will just drag it in here, place it somewhere. Now I see that it's a little bit too big, so I will just take it down to 30 or something. So it fits. Now it's better. I will place it. I don't want any title here, so just remove that. And I will go here and apply a view. So I take this Impact 3D main, like this, view template, sorry. So this is basically it. The only thing I need to do now is to create a new XML file, so Impact knows that we have this new 3D view. So, and also I can decide, so here I have the 3D ortho one. I just make sure that it's 3D ortho. I can add spot elevation to this type of view, and that's the only thing I can add. But let's say there was a plan view, then I can say I want custom materials or the openings to be dimensioned here. But I don't want the spot elevation, so I just unactivate that. I just want the representation. So now I hit apply, and now when I close it, it's finished. I can take another element now, and I hope this one is changed. So I will I hope this is saved. I will just try. Yes. So the reason that it takes a little bit of time is that Impact needs to generate all the sheets, place all the views, and then place all the different annotations, and in particular the dimension lines for each component and elements and so on. But now you can see that I got my element here, so I can see the Now I see the mesh a little bit, but I can just, I think that I didn't apply the template properly, but I can just do it like this. So this is a pretty good thing to have on the main drawing. Yeah, that was everything I wanted to show this webinar. And I don't know, Desi, are you still with me? And do you know if we have any questions that we can continue or finish up with?
Yes, hello everyone. We have had some questions on the during the webinar, and I can try to just go briefly through them. I think it's questions that are very interested for all of us participating today. I'm going to start with the question regarding Impact Library Browser. And a user is asking if where we can find that in the newest version in Impact 16. So the good news about Impact 16 is that we have actually merged the Revit standard into the big Impact standard. And the Impact Library Browser as a functionality is no longer necessary for us, because in the old version, in 15, it was showing this separate folder of Revit families we had. But in the current version that you're seeing right now, and Linus is working with, the standard of Revit is merged in Impact standard. So this means for you as users that first of all, you have a faster way to navigate through your standards. You have better structurally made standards. If, for example, if you want to find casting materials, they are going to be placed in one folder in the Impact standard, no matter whether you work with AutoCAD or Revit. This means it's easier for administrators to navigate. So that's why we don't need any more Impact Library Browser, and the standard of Impact is way better structured. And I want to give you an example. I think casting materials is a good example. So Linus, please, can you please open the standard for Impact 16?
Yes. For the
yeah, it's good just to give a quick example. It's way better just to visualize what we're talking.
Yeah.
Yes. So in Impact 16, as you see, we don't have anymore a separate Revit folder, and it's because the Revit families are placed together for casting materials, are placed together with all other casting materials. So when Linus goes in casting materials, we can see a DVG folders that are the folders used in AutoCAD. But then you can also see some folders for Revit families. So here are our families too for Revit. And if you are administrator for Impact, I promise you, you'll be really happy about it, because you don't store two places anymore. In Impact 16, you store one places and you navigate from one place. And another question we had during the webinar, which I think it's good to repeat here, is a user asking if we can, where we can have documentation of our components in the elements. Can we make some kind of documentation, how many casting materials we have in our elements, or how many reinforcements? So yes, we can. In Revit, you can either use Revit schedules, which are very used by not only by Impact but also Revit users. But in Impact software, we also have a tool called Impact Report tool. So once you save the elements in this building, for example, that you see at the moment, you can go in Impact Report tool and make a report in Excel file documenting, for example, how many bars, how many square meters of mesh, how many casting materials you have in the whole project, in elements from 1 to 100, number 1 to 100, in one single element, there is a lot of possibilities to make reports in impact. Yes, so this was a sum up of the questions we got through the webinar.
Yeah, and I saw some new ones that I just want to answer as well.
Yes.
One of the viewers asked about when I inserted the cost materials with the Smart Sim and or Smart Cost Material and the Sim templates, and he asks if I want to change the position or delete some, how will that like affect the rules that I talked about when implementing? So both of these functionalities are basically just placing the cost materials into the model. So whenever that's done, I can manually move it however I want to, because each are individual instances now. So the rules are basically just used when you apply the cost materials, and when that's done, they are yeah, is basically the same as if you had inserted it through the draw cost materials as I showed in the beginning with this cost material created. So I hope that was the answer. And then we probably have time for some more. Let's see. We can take this one. It's from the same guy. Can SIM numbers contain letters only, or is it only restricted to numbers? And the answer is yes. In our standard, we have decided to just use numbers here. But let's say that for this cost material that I created, that I want to, yeah, if I wouldn't say 0398, this one wouldn't work now, but I can just give an example. So let's say it was FPL, yeah, let's say 14 is the number of this one, let's say. Then I can just hit OK and load this family. And if the SIM mark parameter is set to FPL 14 in my family, I will be able to connect it here. So you're not restricted to only numbers. You can do letters as well. Yes. Perfect. But it doesn't look like we have any more questions that could be relevant. And if there are some hidden questions that I don't see, we will answer them when we go through this list after this webinar.
We got actually just one more. I think it's
okay. I don't see it.
It's a good one. For Holocaust slabs, could additional rebar be added and detailed? For example, a cantilever. And the answer is yes. You can, in Impact Revit, you can use impact reinforcement, for example, as Linus showed you for walls. We have templates that can add bars on openings, on edges, and mesh. But if you want to use a specific reinforcement, like in you asking Wesley, I think yes, for a cantilever, then you can use the Revit Rebar tools, just as you know them. So it's possible to add additional reinforcement. You can also use add-ins for reinforcement if that's what you're using currently. Yes.
Great that you picked that up. Somehow this was hidden, but yeah, super. Do you see any more hidden questions, Desi?
I think that was until now, and we answered all of them that I see.
Super. But yeah, thank you very much for attending, and thank you, Desi, for helping out with answering the good questions from the viewers. I hope you like this, and if you want to watch it one more time, it will be uploaded to our YouTube channel, StruSoft. it's called, probably by tomorrow. So yeah, thank you very much, and have a wonderful day, everyone.